Floods and droughts are natural hazards that cause significant damages, both in terms of lives and economic losses. Services like the Copernicus Emergency Management Service are fundamental for communities to cope with these hazards. However, the service is not perfect and it faces challenges that CDFD will help us improve.
CDFD is a Horizon Europe research project which aims at advancing the Copernicus Emergency Management Service early warning system. By advancing this tool, we are making flood and drought prediction more reliable worldwide.
One of our main objectives is to improve the hydrological model of the Copernicus Emergency Management Service. There were some modules that were not included within the model, such as wetlands, reservoir operation, and groundwater flows. We are working on including these processes within the model across different regions of the world that might be affected by climate disasters, such as drought and flood.
So the second objective of CDFD is really to use satellite data and microsensor data. And why that is important is that this Earth observation data are really underused in global applications like flood and drought forecasting. So what we're going to do is that we're going to use this information and include that into our forecasting model chain and look at how it improves the quality of our hydrological forecasts.
The STEM system right now, it's including a lot of tools and systems that can we use for the forecasting and the monitoring of drought and floods. But with the climate change, there is an increasing variety in these events, so we want an increasing variety of tools to monitor and forecast in those systems. So the third objective of the project is to include new tools for the monitoring and forecasting on floods and drought flash events, including seasonal forecasts of drought and also tracking of drought events in time and space.
The project is divided in two phases. The development phase, where we focus on two highly instrumented basins, which are the Bima Basin and the Danube Basin. This way we can test and refine the new algorithm and set strong foundations. And the second phase of the project is the validation phase, where we will apply the improvements on 3 basins, each with unique hydrological conditions, which are the Niger, the Parana and the Juba Shebele in Kenya. The goal of this phase is to show the global applicability of our development and to estimate which one showed the best potential for operational implementation.
The outcome of CDFD will benefit governments, organizations and decision makers in taking better decisions in terms of floods or droughts. It will also benefit citizens. They will be warned about these hazards. And lastly, it will help or provide scientists with better hydrological modeling and better data for their future research.